What is happening? What's happening? What is happening?
If you are wondering about fireworks, you come to the right place. Now, let's start with this question. What are the components to fireworks? There are basically three components. One is fuel, second is the oxidizer, and third is the binding agent. Today, we'll focus on the oxidizer, and it is the substance which is responsible for the colors of fireworks. To explain what happens in the atom or the oxidizing compound, we'll use Bohr's model of an atom. The Bohr's model of an atom was put forward by Niels Bohr in 1913. He suggested that electrons have fixed amounts of energy in a specific orbit. This energy possessed by the electron is dependent on the radius of the nucleus. In other words, electrons in different orbits have different amounts of energy. For the electron to move away from the nucleus, from inner to outer orbit, it has to take energy. The electrons will be in an excited state. The electrons will have to return to ground state, however. It will need to give off energy, and it will move from outer to inner orbit, along with moving nearer to the nucleus. Let's move on to emission spectrum. You may wonder what is it, but it's quite simple really. It is light of certain wavelengths emitted when electrons return to ground state. This may occur after substances are shortly heated to high temperatures. It also can be the visible and ultraviolet regions of the electromagnetic spectrum, and it can be represented as a series of lines. It's called the Balmer series. Now let's move on to the process. So when we combine everything together, we will get an explanation, which is when atoms are heated up, electrons will have to take in energy. They will be in an excited state. This will cause the electrons to move to an outer orbit. However, at the same time, electrons will have to return to ground states. The process is called stimulated emission. The protons will collide with the atom in an excited state. The incoming proton will force the electron to jump back to its original state. At the same time, this will also emit another proton. The electron will move from a higher to inner orbit, and this will emit wavelength or visible light. Now, let's do a simple experiment we can do in the lab. The barium ion produces a yellowish green flame. However, in the video it seemed like it's a bright yellow color. However, that's not true. Now it's emission spectra. Let's move on to the next clip. There was a clip on sodium chloride. The sodium ion produces an intense yellow flame. It may appear to be orange. Now it's emission spectra. Let's move on to a final clip. This is potassium chloride. As you can see in the video, the potassium ion produces a pale violet flame. Now it's emission spectra.
Now we get it.